The Bluetooth device is ready to pair.
Hello guys, welcome back to my YT channel again for another vlog, another topic for chemistry. Okay, so I hope you are enjoying my vlogs for chemistry, and I hope you are staying tuned to me today or tonight. I don't know the exact time in another parts of the world, but I hope you are watching, and I'm very happy for that. Okay? Oh my gosh, wait. Right? Of course, I need to do the simultaneous in order for my friends also on my FB account can see me during my discussion of this academic subject so far that we are, opted to forgot. Okay, I know that. Okay, so our topic for today is all about colligative properties. Oh my gosh. It looks like strange, right? The word colligative. Okay, but somewhere along the way you will enjoy this. Oh my gosh. Okay, you will enjoy this topic. Okay, so colligative properties. Okay, colligative properties. Okay? Oh. Actually, guys, this is a combination of physical and chemical properties. And then physical change and also chemical reactions involved, but not really common. Okay, but sometimes it will be a mixture for that chemical and physical changes will be involved, right? Okay. Okay, so number one we have, but before anything else, we need to define the terms colligative properties. So colligative properties, it has to do something with the dependency of the solute concentration or the solute particles, but not to the identity of solute or the solvent, or not to the nature of solute and solvent. Okay, things like that. So with it, concentration, take note, concentration of solutes most of the times. Okay, things like that. Okay, solutes of the particle or the particles, and it has to deal with concentration. Okay, first we have the, okay, boiling point elevation. Okay, boiling point elevation. Okay, elevation. Okay, boiling is a physical change, right? And then elevation meaning to elevate. Okay, to increase. Okay, so it has to do with positive sign, right? Okay, then boiling point. What do you understand by boiling point? Okay, in our elementary, I think this has been discussed. This had been discussed in grade 6 or grade 5. Okay, elementary. We say boiling point. Okay, it's gonna be when the vapor pressure is equal to the atmospheric pressure. Okay, things like that. So the atmospheric pressure here is what we call the surrounding pressure, or let us say the area where you, for example, where you boil the water, where you cook the water, so surrounding pressure. Okay, surrounding pressure or the environment pressure, right? It depends on what particular place you are doing the physical changes. Shut up. Okay, so vapor pressure, it has to do something with the pressure of a gas, okay, exerted above the liquid. Exerted above the liquid surface. Okay? Things like that. So this is gonna be above sea level at time will be temperature, pressure, 1 atmosphere, things like that, okay? At pressure, 1 atmosphere above sea level. Okay? Things that are above sea level, let's say 760 mmHg, things like that, okay? We cannot say temperature is equal to 0 because boiling point, our temperature here will be 100 degrees Celsius. You get the point, but our basis here is at sea level with a pressure or atmospheric pressure of 1 atmosphere. Okay, boiling point with the vapor pressure is equal to the atmospheric pressure. Or we will say as when the pressure of a gas exerted above the liquid surface will be equal to the liquid surrounding pressure. Okay, for example, if I have a beaker here inside the room, I will heat up with a Bunsen burner, things like that, okay? So, we have the temperature inside the room, okay, like that, and we have the temperature also inside the beaker. We have also the pressure inside the room, and we have also the pressure inside the beaker. Okay, the outside pressure here, the atmospheric pressure here, will be equal to the pressure of this gas in the vapor phase above the liquid. Okay, things like that. So if it equals, then it will boil. That's why it is 100 degrees Celsius. Okay. It's a point. Now, if you add solute, especially the electrolytes, or let us say non-volatile solute, what do you mean by non-volatile solute? For example, sucrose, fructose, glucose, galactose, things like that. So, meaning they are really a molecular compound, usually non-polar, things like this. Okay, then it will increase the boiling point of the solution. It will elevate. Okay, that's why boiling point elevation. Okay, get the point? Diba? Then you may also wonder why, for example, you will cook food and then why you will put the salt not in the boiling stage. Common sense, because it will boil directly and then the taste of the salt will disappear quickly, right? So you should put that somewhere along the way before the boiling point so that the taste of the salty or the salts will evenly distributed into the solution, like a soap solution where, let's say, bulalo, sinigang baka, like that, okay? Get the point? You will never put that after boiling point. You will put that before. Because it will alter the taste of the salt and it will not be tasty anymore. Get the point? Ganon. Second, okay? So here is a liquid surrounding pressure because this is the liquid inside the beaker. That's a liquid surrounding pressure. So this is the surrounding of the liquid. It's a liquid surrounding pressure. But if you don't mean also liquid, it's not liquid anymore. For example, if you boil solute only, there's no water. For example, you will just heat the bulalo without any water, without any soap. You will not say vapor pressure is equal to the atmospheric pressure or the liquid surrounding because that's no longer liquid. You will just only say vapor pressure is equal to the surrounding pressure, okay? So, things like that. Because all substances will boil talaga siya, whether solid, liquid, or gas. Okay? Things like that. The fastest will boil will be the gas because it's already in the vapor phase. You get the point? So the molecules are very far apart with each other. Okay? Things like that. Number 2, class, we have the freezing point depression. Freezing point depression. So that's why in European countries or somewhere along the way in the Western countries, they put salts in the snow areas so that the freezing point will decrease. Okay, things like that. So this will be involve or literally belong to freezing point depression because too much cold there. Okay, you need to depress the the salt and the solid, sorry, of the ice. Okay, like that. So depression, meaning to lessen, to reduce. Okay, to reduce, to lessen, to dwindle, to minimize. Okay, what else? A lot, right? Okay, things like that. Number three, we have the vapor pressure lowering. Okay, the vapor. I love this vapor pressure lowering because this is also one of the topics in our physical chemistry. I love it really. Okay, in our liquid extraction, ternary, liquid solution like that, binary. Okay, solution, things like that. So before pressure lowering, and it's so enjoyable, and we buy a lot of graphing paper, and then we need to graph everything, the vapor pressure against the mole fraction, and then we create a graphical representation of our yes, drawing will be happening to the gas, to the liquid after, right? Okay, so vapor pressure lowering. So obviously, the vapor pressure will lower. Okay, get the point. So later we will explain this why the vapor pressure will lower, right? Number four, we have the osmotic pressure. Okay, osmotic pressure. It regards with the osmosis. Okay, by using a semi-permeable membrane to to convert, for example, to convert seawater into pure drinking water. So the process will be reverse osmosis, things like that. So the osmotic pressure theory will be applied there, things like that. Okay, get the point. So, enumeration. What are the four colligative properties? Boiling point elevation, freezing point depression, vapor pressure lowering, and osmotic pressure. Define colligative properties. Colligative properties depends mainly on the concentration of the solute particles, but not on the nature of the solute and solvent or the identity of this solute and solvent. Like that. Okay. Now we need to do the formulation or having the formula each. Okay, so let's start. So you already write in the blank sheet of paper the four. Okay, so that during our examination you can really answers. I know you love enumeration, things like that, listing out like that. Okay, so our world will be revolving in that. We are in high school, okay, in our college, but not so much in college because there's a lot of problem solving. But for for our other subjects, too much like that, right? Okay, so our formula for boiling point elevation. Okay. Okay, take note. Boiling point elevation. So the symbol will be delta TB. Okay. B stands for boiling point. Delta stands for change. Okay, so our formula will be the eleboscopic constant. Okay, take note for the terminology. Eleboscopic constant, molar boiling point elevation, or boiling point elevation constant. So you can have the three names for this or terms. Okay. Sometimes it will be called eleboscopic constant. Okay. Molar boiling point elevation constant. And then the third will be, okay, boiling point elevation constant. Okay, things like that. Or shall we say boiling constant directly. Okay, but use really is the boiling point elevation constant in different books. Okay, then if you research deeply, there will be another term, eleboscopic constant. Okay, times the molality times the I. So the molality here is so confusing, right? Because it will create ambiguity. in the declaration of our variable, because small m also in our chemistry lecture will be mass, right? So in my case, I will really use molal, okay, O-L-E, to determine molality. Molality, the unit is molal. Because if I will put M, it will confuse me a lot in solving the molecular weight in terms of the mass with the small letter M also. Really, okay? That's why. But if you are really clever enough, you will not be confused, right? But in my case, I will really easily get confused. Okay? You get the point. But if you're convenient, so that's your style, so you have the freedom to do that. But in my case, I need clarity. Okay? Things like that. So I be careful also, take note. Based on the research in my college days, some books will not put I. Why? Because some substances have an I of one only. So you will be wondering, where's the I here? It's been lost. And sometimes the books will not explain really understood. Okay, just like our teachers sometimes, right? Understood, chuvas. And then the students cannot understand where this variable has been lost. Like that. Okay. Then we will be the one to analyze that has been lost because it was not discussed by the teacher at the end of the discussion, right? Sometimes we interpreted in our own way. Right? And this is really the drawback or the issue. Maybe we interpreted it wrongly. As long as we know, because there's no like this, because we interpret in our own way. Though sometimes logical, but sometimes we need really to discuss in the part of the instructors, okay, and professors, especially in college. Okay, so it doesn't mean that you are now in the college, you will not explain explicitly and extensively, things like that. Okay, got the point? So it should be again discussed in clarity. You got the point? So that the students will not be wondering why. Okay, things like that. So, for example, I will become one. Sucrose, carbon 12, H22O11, the table sugar we have, refined sugar. Okay, so we have the molecular mass or molar mass or molecular weight of 342 grams per mole. So there's point something something chuvas, but I don't recall because that's too negligible to consider. Okay, so your I in this particular substance is 1. Now, if your sucrose will be mentioned in the problem solving, you don't worry with the I because there's no value with it. It's 1, but not 0. Because anything will be multiplied by 0, it will become 0. In math rule. You got the point? And then anything raised to the power 0 will be equal to 1. Right? If you can remember. And anything multiplied by 0 will always be 0. So it's impossible to put 0 here. You get the point? Instead, not putting. Okay? What else? Okay, let's say glucose. Okay, glucose also have an I1, meaning Van Hoff factor. Okay? Van Hoff factor. Discovered by Mr. Van Hoff. Okay, that's why most of the terminologies in chemistry are derived by the scientists who discovered. Okay, things like that. Okay, for glucose also, 1. Okay, C6H12O6. Okay, glucose is the basic monomer of sugar and carbohydrates. Okay, so meaning to say, sugar is a polymer of carbohydrates. You get the point? Things like that. And then it is a saccharides family. Okay? Then, sucrose is a combination of 2 monosaccharides of glucose. Meaning to say, this sucrose is disaccharides. Okay, then this glucose will be monosaccharides. Okay. Now sometimes in problem solving also, they don't state anymore the glucose. They don't state anymore the disaccharides, but then they will just give the molecular weight. So the tendency is you need to search a lot. Okay, but for me, at the time in my college days, I will really memorize so that it's easy for me to understand what is the amount of blah 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 so and so that will be reacted. The monomer sugar will try to react, but there's no other monomer sugar except for glucose because the other monomer is not stable. Okay, it's only glucose is the most stable of all the basic monomer units of carbohydrates. That's why we said glucose is the building blocks of carbohydrates. Okay, meaning the representative of all sugar family is the glucose. Okay, and it is popular as our blood sugar. Things like that. So, 6 atoms of carbon, 12 atoms of hydrogen, 6 atoms of oxygen. So, these are mainly found in our kabush, bread, rice, and any energy-giving foods, the starchy foods. Okay, get the point. That involves a lot of yeast, things like that, or these starchy foods really. Okay, get the point? Ganon. Right, okay. Now, one also am I, then a lot of sugars. One is I. All sugars, okay? One. So if we really identify, then no need to be worried with I, huh? Okay, things like that. Bantoff factor. So these are the total of solute particles when it dissociated into the water or when it ionized into the aqueous solution, things like that. Okay, so we can only have our I here if we have an ionic substance or ionic compound that will dissociate upon adding water to produce solution. Okay, then if you add water to the particular substances and we mix together, then it is really a solution of water and a solute. Okay, get the point? Things like that. Okay, now, so it will be, for example, enough na to sa I is equal to 1, ha? Okay, now, how about I is not equal to 1? Okay, so for example, I have here, these are ionic compounds, meaning metal plus non-metal. This is very important part in our calculation because if you don't understand really, we cannot we cannot really get the I. We will just guess. Because some teachers are not really, elaborative. They don't really expound, they don't really expand their discussion about I. And sometimes, me before I am only interpreting in my own way. If I cannot understand, I will go to the library. Okay, things like that. Okay, so to avoid that also, so we need to discuss comprehensively each term of the particular formula to erase this confusion, diba? So that the students will not be perplexed. Get the point? Things like that. Okay. For example, I have here, let's go to the higher. Let's say iron 3 chloride. So, yeah, okay. Iron 3 chloride. Like that, right? FeCl3. Now, you will not put parentheses if the other one has no charge, only negative one, huh? So erase this. Okay, you will only put close and open parentheses if both elements in a compound have the charges, then it will become the subscript. Okay, with one another. Okay, exchanging the charge. See? Like this. Iron 3 chloride. Okay, strictly saying iron 3 chloride, it's not iron chloride. Again, because there are two charges of iron chloride, iron 2, iron 3. Okay, things like that. So, how can we do this? Okay, plus water. Okay, so this is gonna be displacement type of chemical reaction, right? Double displacement or double replacement. But we are not concerned really for the stoichiometric chemical reaction in the dynamic equilibrium between the forward reaction and the reverse reaction. We are not concentrating with that. We are concentrating with the dissociation and ionization of these ions. Okay, so you will say Fe positive 3 plus 3 chloride negative. Remember this, all subscript will be in the coefficient when we count the Van 't Hoff factor or the Van 't Hoff value. So now you will say coefficient. So 1 plus 3, 4. Things like that. Because total solute particles of the particular compound. You get the point? Total solute particles of a particular compound. And our compound is composed of iron and chloride or chlorine. Then it will dissociate, it will become chloride. Right? So, the subscript will be on the side automatically. Okay, so 3 plus 1. Then it will change depending on our compound. Let's say I have barium nitrate, right? No, I need to have the charges of both. Let's say barium carbonate. Barium carbonate. Okay, like that. So this is the time you will put parentheses because both have charges. So the charge of barium will go here too, and the charge also of CO3 too, but it will be cancelled. Sorry. If it will be cancelled, no need to put the parenthesis also and the subscript. Sorry, we need to pick another. Okay, let's say aluminum carbonate. Okay, on the spot kasi guys, I don't prepare what to talk. Okay, I don't prepare what examples. That's on the spot. So aluminum, let's say aluminum, okay. Aluminum 3 carbonate. Oh, this one. So 3 here, then 2. Too much charges, right? Okay, so aluminum carbonate, it add water. Okay, it will become 2 aluminum positive 3. Okay, your positive 3 charge will be an indication that you put that on the other subscript, on the other polyatomic and ion, because this is metal plus non-metal. The non-metal here is either gases or polyatomic and ion with negative charge. Okay, let's say carbonate, and then put the 3 because this is not the subscript. This is really the original carbonate of CO3. Then 3 put beside the negative 2 here. Okay, how many Van 't Hoff factor or Van 't Hoff number here? So 2 plus 3 is equals to 5. Okay, 5 is our I here. Okay, things like that. As the moment I teach you already, then you need to apply that in our problem solving. You get the point? Things like that. Okay, now take note guys, in dealing with vapor pressure lowering, especially for the computation of your mole fraction of the liquid phase. Okay, yeah. Mole fraction of liquid phase, because we have also mole fraction in the vapor phase, especially if you have the liquid binary solution. It's good for that. But if you have also solute and liquid, there's no problem with the other mole fraction. But if it is liquid, you have 2 mole fraction. The mole fraction of the liquid phase and the mole fraction of the vapor phase. And you should be clever how to use this vapor phase and how to use this liquid phase, because the moment you will interchange that, you will become wrong. Okay, things like that. And then you need to remember the technique. Okay, so that, and then coupled with understanding. You get the point, things like that. Okay, you get the point. Okay, take note for the vapor pressure lowering. Okay, what's the important there? The mole fraction, right? Okay, in the mole fraction, guys, with regards to ionic substance, be careful. Because the number of moles here in your mole fraction is no longer the moles original that you try to compute every time. And this is also, shall I say, the most important thing that some of our teachers did not taught to our chemistry students. Even me, I only realized this after passing the board examination. When I try to review everything, because normally guys, when I talk the examination, I will go back and then really retrieve where I got wrong, where I got correct, so that I can estimate if I pass or not. That's my culture. things like that. For example, if I take the Bush Safety International General Certificate exam, if I found it, oh, I have so many wrong there. Okay, I need to review. Even though the examination had gone, I still have to review where I got wrong, like that. So that's my nature. Okay, I found there, oh, so I was sad, things like that. Okay, because, Char, I used the wrong way of understanding regarding the ions about the mole fraction. You get the point? Things like mga palangga kong hintalan mo, Char. Okay. So, Charis. So, muna akong ikakultin niya ng higayuna. Okay. Diba guys? Wait for a while guys, saka nagubat ko. Can you still hear me, my voice? Or not? Charis. Can you still hear me, mga palagingging? Okay. Can you still hear me right? Okay. Maludaw ko nila, oy, sabi nila. Charot! Okay? Like that. Diba guys? You cannot see me here, but in the other phone you can see me. Like that. Okay. Oh, you can see me here? Oh, perfect! Okay, things like that. Oh my gosh. For example, guys, if I have, let's go to the basic strong sodium electrolyte. Strong electrolyte. Let's say sodium chloride. Strong electrolyte kasi yan. Because it will completely dissociate into the water and ionize into the solution. Okay, that's strong electrolyte. Okay, now, how can you say in this manner? For example, if I compute that, what is the mole fraction of chloride ions in sodium chloride? So I will say molecular weight of chloride. You will never use chlorine. You got the point? So this is, molecular weight of chloride, okay, is equals to the mass of chloride over the moles of chloride. Right? Things like that. And then sodium positive molecular weight, you will say mass of sodium positive and mole of sodium positive. Like that. Okay, now, is this true or correct? This is the principle of chemistry. If we try to base this with mathematics, we will just doing the patterning. We pattern. We just do the sequencing. Okay, but in chemistry, there are rules to follow. We cannot basically the same follow mechanics. Here is wrong. X. Because how can you determine the mass of a chloride? It will dissociate to water. Can you distinguish that? No. Okay, X mass of chloride. So molecular weight, how can you say the molecular weight of chloride is already having a charge? Okay, the moment it will yield a charge, you can never exactly get the atomic weight because it is not neutral compound or neutral element. We can only get the molecular weight, the atomic weight, if it is a electropositive element or electronegative element, meaning there's no charge. The charge will just be appearing if you try to react that to another compounds or water, or it will dissociate into a chemical reaction. But if it is not really reacted yet, you don't have to break that and have a charge. For example, if I have oxygen, like that, okay, get the point? Oxygen is zero charge. You get the point? Because it's neutral. But the moment it will react to carbon monoxide, carbon dioxide, it will now become O negative 2. You get the point? This is the basic principle of chemical reaction. You get the point? So the moment you say sodium chloride alone, the charge is 0. You get the point? Now, if you will dissolve that with water, then there are charges of sodium ion, there is also charge of chloride ion, things like that. But it will never be true in sugar. If you try to put sugar in the glass of water, it will dissolve. It will never be dissolved unless you will stir it. Why? Because sugar is not electrolyte. Okay? It is non-electrolyte. You will only dissolve that by applying internal energy, by stirring it out, by a spoon or whatever. But under normal circumstances, it will not really dissolve. You get the point? It will also dissolve if you heat it. Okay? Heat it, boil it, or if you try to expose that under the heat of the sun. But under normal situation, no, it will not dissolve. You get the point? Things like that. Okay, observe that also by yourself. Actual experimentation. Okay, get the point. Things like that. So if this is wrong, ha? Our correct in this expression is the mole of chloride lang talaga. Because the moment it will become a mole, it will be expressed into ion. Okay. Now, what you will understand here, you will use the mass of the whole compound in here. Okay, you will never say the mass of chloride like that. Okay, no. Okay, you get the point. So the mass of sodium positive, how can you determine the sodium positive? You get the point? Things like that. It should be sodium only. Sodium solid, chlorine solid. Okay, letter S. Small letter S. You found that in the books in chemistry. Small S solid, small L liquid, small G gas. Okay, AQ aqueous, meaning it's have water in the solution. Okay, now for example, if I will say dissolve 25 grams of sodium chloride in water. Okay, like that. And then your water will be, for example, only have, for the purpose of discussion, I have 10 grams of water. Calculate the mole fraction of chloride. Right? How can you do that? So you will start with sodium chloride. Okay, then add to the chloride. So you will say 25 grams of sodium chloride because the chloride comes from sodium chloride. Just like a parent, the baby coming from the parent. Okay, when you try to trace the DNA or the family history according to the hereditary trait or offspring for that particular person, you may trace the parents, the forefathers, like that, to establish the relationship, blood relationship. In ionic substance, it's also like that. Since chloride coming from sodium chloride, so you need to start first in your computation with sodium chloride. Okay, so sodium chloride. So, molecular weight of sodium chloride, sodium 23 plus 35.45. Okay, 35.45. Atomic weight of chlorine, 35.45. Atomic weight of sodium, 23. So, 58.45. Okay, so this is gram and 1 mole. We need to say, in every 1 mole of sodium chloride, you produce 58.45 grams of salt. Okay, in every 2 moles of sodium chloride, you produce 58.45 times 2 grams of your sodium chloride. In every 3 moles of sodium chloride, we will produce 58.45 times 3 grams of your sodium chloride. Because there are also basic questions like that. For example, only one sentence like this. How many grams of 8 mole of sodium chloride? It looks like strange, right? But actually, it's very easy to compute. Get the molecular weight and times that directly kalas. That's the mass. Okay? But it looks like very strange in our comprehension because our teachers never taught that way. Okay? But that is analysis. Analysis meaning it's not being taught. Okay? But it's part of what being taught. But it's just happened that the teachers don't give problem solving related to that particular of how it is being solved. That's why we need to understand, because the moment you modify that a billion of times, you can still answer that. Okay? Because the moment you memorize that, how it is being solved, then you will become dependent to the way how it is being solved, and then you repeat the way it is being solved to another problem, even though it will not apply already. And this is the most cases why students and examiners failed. Because science is not patterning, it's not sequencing, it's not an abstract reasoning just like math, that if we do, there's gap 2, next gap 4, next gap 6, gaps next 8. So sequencing, right? Or chronological in order. In science, it's not. You have to follow the basic understanding. Okay? You got the point? Nakita foundation, atong weapon. You get the point, things like that. So that if the teachers will fail, we can stand alone. You get the point? So meaning, I am teaching in my vlogs to be independent, to be resourceful, to maximize our academic potential, that we can stand without them in the future. You get the point? Though they are teaching us a lot and we will be grateful to them, but the rest of the learning is coming from us. We should not blame them. Okay? Things like that. Okay. So I think we can also say, because the way they talk is not effective, it's okay. But the total learning, I mean, you will never blame them of the total learning, because they are just an instruments in order for us to learn. The rest will be coming from us. Okay, things like that. Okay, now we have grams here of sodium chloride. Okay, this is also sodium chloride, understood, huh? Okay, because the moment, if this is not a sodium chloride, you cannot cancel, because they are not the same compound. Okay? Things like that. So grams, sodium chloride, cancel. Okay. 1 mole. Now, you try to determine the ions now, because we need to get the mole fraction of chloride that will dissolve in water. We are not telling that we need to get the number of now mole fraction of sodium. Okay? It's not the chloride and the sodium ion. In here, we need to solve the chloride ions. Okay. Now, here. Okay. Remember, we don't need a chemical reaction here, huh? Because this is ions and dissociation. We don't have to go with the balancing chemical equation. This is not also stoichiometric equation that we need to get the number of moles there, to get the gram, the moles, and everything, the mass. It's another story here, huh? Okay. Things like that. So, 1 mole of sodium chloride, right? Ganon. Okay. So, what you will understand here? Okay. So, if there's 1 mole of sodium chloride, so again, 1 mole of sodium chloride, right? Okay. So, cancel 1 mole of sodium chloride. So, how many chlorides in our dissociation of sodium chloride? So, sodium positive plus chloride negative. So, there is only 1. So, 1 chloride ion. So, cancel them all like that. So, 25 divided by this is your chloride ions. Okay, things like that. Since this is small, you will say 1 mole of chloride ion. Okay, 1 mole of chloride ion. You will still carry the word mole because we are talking of mole fraction. You are not talking of ion fraction. You get the point? Remember also the naming. Okay, mole fraction is what we are trying to get. Not ion fraction, not mass fraction, not volume fraction, not pressure fraction. So the word mole is what we're trying to obtain. So, not siya. So you will say, the mole of, okay, chloride over the mole of, this, pares, sodium, positive, plus the mole of chloride, negative. So the mole of chloride, we can solve already, right? If you try to calculate this one. And then the same thing what you will do in our sodium. Okay, sodium also, sodium. So, like that. Started also with sodium chloride. This one also. You get the point? So 1 mole of sodium chloride, ganon, ganon. So 1 mole of sodium chloride, then sodium also will become 1 because they are equal. 1 mole of sodium positive plus 1 chloride of negative. Now, in this case, guys, if there's no subscript, your mole and atom will be the same. This is only the case where the atom and mole will be equal if there's no subscript in each element in the compound. Now, if there's subscript in each element of the compound, the number of atoms and the number of moles are not equal. You get the point? Because in the first place, the definition of mole is not the same as the definition of the atom. You get the point? You get the point, mga palangga? Ganun siya. And always written beside the element and a compound is always the number of mole. It's not the number of atoms. So if I will say 2 moles of water. So I will not say 2 atoms of water. I will say 4 atoms of hydrogen and 2 atoms of oxygen. In fact, I will never say also 2 atoms of hydrogen gas plus 2 atoms of oxygen gas, because the moment you say gas, gas, chuvas, that means there's a subscript of 2. So I will only say 4 atoms of hydrogen plus 2 atoms of oxygen. You will never mention the gas, because the moment you will say gas, it will become H2, hydrogen gas, O2, oxygen gas, F2, fluoride gas, Br2, bromide gas, bromine gas, sorry. Okay, iodine, I2, iodine gas, like that. Okay, but if there's no 2, that's not a gas. Okay, even though they have the same parent element. Okay, for example, O3. There's a 3 subscript of oxygen. This is not a gas. This is the ozone. Ozone is the chemical component of the layer of the sun. This is the one who will protect us from too much extreme heat of the sun. Once the ozone layer will become thinner because of the presence of carbon dioxide, then it will be problem for us, causing cancer, like that, skin irritation. Now, so why? If you try to react the CO2 of an ozone, what will happen? It will eaten up the atoms. Okay, it will eat the atoms of oxygen to be donated to the CO2. Things like that. You get the point? Now your CO2 will become carbonate, and then your O will become oxygen gas. You get the point? Okay, it will be donated. Okay. You get the point? It will not become O4. O4 is not existent in the nature. That is, if you try to be, let's say, hypothetical, this is gonna be tetroxide. Because this is 4. It's a O5, pentoxide. Right? O6. But, this will only be true if there's partner element. Let's say, dinitrogen pentoxide. Dinitrogen heptoxide. But as a solo, stand-alone element, it will never exist up to 3 only, which is the ozone. Okay? The O, the O2, and the O3. I'm not saying it will exist. It will exist, but it will react to another element as a compound. This O5, O4, O6, O7, O8, O9, and O10. You get the point? O10, meaning to say 10 atoms of oxygen. You get the point? Things like that. So, muna siya yung mga basics, chuvas, ha? Okay, so after getting the mole ions, divide mole ions of chloride, mole ions of sodium plus mole ions of, this is your mole fraction of chloride. I think so this will be discussed also, but not very common, right? I remember, maybe I was sleeping, but I don't remember it was discussed fully. Okay, you get the point? Things like that. Okay, number 2, kibi kalas no, molalitita, molal. Kataas na akong explanations guys, oy. Diba? Char. Okay. Molal. Molal is the unit of molality. Okay. Molality. Okay. Then, this will become mole of solute, okay, over kilogram of solvent or kilogram of water. So, most of the kilogram of water, but sometimes kilogram of solvent, it depends on the liquid you are putting in a mixture. But common is water kasi. You get the point, things like that. Okay, mole of solute over kilogram of water. Okay. So, molal is expressed in small letter m, but we'll just use molal. Okay. Now take note, kilogram of water. Okay. Kilogram of water. Now, most of the problems given in grams. Okay. What you will do? You will convert the grams or you will convert this molal. You will never touch the molal because this is the standard unit of the molal. The other will adjust. And later on will come back to grams. You get the point? Because this is the standard of, you can never say in molality, mole of solute over 1,000 grams of water. Though they are numerically equal, but this is not the precise condition of molality. It's always kilogram, even though 1,000 grams is just the same of 1 kilogram. Okay, later you will convert that to grams, no problem. But in a substitution, you need not to change this kilogram of water. Huh? You get the point? So others will adjust. Okay? If the solute is mentioned, there are grams. But we will be happy if the grams mentioned, if the mass will be mentioned, there are kilograms already. Perfect. Okay? Kilograms. So no need to convert. You get the point? Things like that. But this is a trick here because you need to understand only if you break the units of the molal. You get the point of molality. But if you don't break that, then it will become a problem. Okay? So you need to be specific. Okay, you have to be particular. Things like that. You get the point? Things like, now, molal, no? Ang value sa atong KB is 0.51 degrees Celsius per molal. So, I can still remember this because I memorized this in my high school day. Okay, things like that. Okay, and it's always less than 1. So, every time I will grow old, it will be in my mind because it's less than 1 and half a little bit. So 0.51. So it's very easy to memorize. You get the point? This is, I love also chemistry. That's why, it's been practiced for a longer period of time. Okay? And it will not, may it vanish the others, but the basic will not. You get the point? Things like that. Okay. Now, we have number 2. The freezing point depression. Okay, point. Okay. Grabe naman. Okay. The freezing point depression is equal to the Kf. Guys, FYI, K stands for constant. But sad to say, it's not the first letter of the word constant. Right? Suppose it will be C. But why the scientists before use K as in kangaroo instead of using C? Because see, constant. First letter is C. Most of the abbreviation, the first letter of the word will be carried over. But here the constant letter K is the first letter. Then why our scientists before using K? Right? So I told you, there's no patterning, there's no sequencing, but based what they do, you will also do in this way. There's no like that talaga, okay? You get the point. Okay? So K also can be a kangaroo, like a codigo, charisma. That's the abbreviation because K is the first letter of a word. Okay? But constant, the first letter is C, not K. Then why are scientists before using letter K? Okay? So You haven't questioned that? Okay, things like that. So Kf times molality, molal, times I. The same I, the total solute particles during your dissociation in the aqueous solution, meaning a unique substance and a unique compound. Okay, not the molecular, okay, things like that. Or not the covalent compounds. Okay, Kf, our value is 1.86 ganon chuva chuchu degrees Celsius over molal. So this is now our cryoscopic constant because that means cold. Eleuboscopic meaning hot. Okay, so cryoscopic constant. Okay, so when I was in my first year of college, I love to use this terminology rather than the common one. Oh, what is a cryoscopic? But I will never share to my classmates, and it's only in my mind. Maybe they will laugh at me and they will say I'm crazy, things like that, because I think they don't love it also. Okay, but me, I love the terminologies like that. I keep on memorizing new terminologies like that in the library. Things like that. Okay, so 1.86 degrees Celsius per molal. Okay, mauni siya ang constant sa atong freezing point. Okay, then memorize that also. It's very easy. 1.86. Okay, pasok sa banga. Okay, now our freezing point depression and boiling point elevation. This is just the same saying new boiling point and new freezing point, because sometimes also in a problem solving they will keep on changing the terms in which the students are not usually exposed. For example, you will say, what is the new freezing point? New freezing point. What's this all about? Is this the change in freezing point? It is the total freezing point of the solution. So sometimes there's clarity on how to understand before we solve, right? You get the point? So new freezing point is just the same as the freezing point depression or the total freezing point, okay, of the solution. Okay, things like that. I will write so that I will not be stuck up. Okay, because so many words in my brain cells. Okay, I need to put this. Okay, TF meaning freezing. T means temperature. So meaning here, okay, the TF only without delta change. Okay, I will put again nakakaloka. Okay. I hate this topic because this is the area when I was confused. That's why I'll share to you very well. Okay. Things like that. Okay. So let's say TF. For the fast learners, I think they got it very well. But for me, I cannot get it very well. Okay. That's why I need to, So TF is equals to, okay, the boiling point of water. So this is not TF. This is TB. Boiling point of water plus the delta change of the boiling point. Okay. So, okay, this is boiling point elevation terms. Boiling point elevation. In a problem solving, they will say, what is the boiling point elevation of the blah 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 so and so? So you need to use this formula. Boiling point elevation. Sometimes they will say also, what is the new boiling point? Without carrying the elevation. New boiling point. Like that. Sometimes also they will say, what is the final temperature? Okay, what is the final temperature of the solution after boiling? Final temperature of the solution after boiling. So taas-taas siya, no? Okay? So, more na siyang variation on how they will ask. So, what is the boiling point elevation of blah, blah, blah? What is the new boiling point of blah, blah, blah? What is the final temperature of the solution after boiling? Okay? Ganon. Now, here, boiling point of water, steady, 100 degrees Celsius. Since we say that boiling point elevation, we carry the sign plus always and forever. because of the terminology elevation. We need to increase, we need to enhance, we need to raise, we need to augment, okay, things like that. What else? We need to intensify, okay, we need to maximize, we need to elevate, we need to, what else? Okay, there's a lot of terminology in English. Okay, use the dictionary. Okay, things as long as it is added, combined, united. Okay, things like that. Okay, what else? Collaborated. Okay, grabe na sa tanong. Boiling point in collaboration. It may be correct also because that is the synonyms of this plus or plus and addition, combined, okay, united, like that, or fusing, okay, or group together. You get the point? Things like that. Actually, you can have so many synonyms of the plus here, okay, things like that. Now, it's very obvious because elevation, right? You don't have to put minus. English will do during your memorization. Okay, now for TF, how can we do this? I need to discuss properly because in the problem solving, para tuloy-tuloy ang ligaya. Okay, got the point? Things like that. Okay, for your freezing point, the pressure is gonna be TF is equals to the freezing point of water. Okay, the freezing point of water. Okay, now, you are telling depression. In English, what's that? Reduce, minimize, like mitigate. What else? So many, right? Dwindle, or let's say truncated. Okay? There's a lot. Okay? So you say minus because of the terminology in English. Okay? So minus. Okay? And also, freezing point of water is higher, 0 degrees Celsius. And some of the freezing point of the substances will be below than 0. That's also another concept again. The water has a very high freezing point, which is 0. The others will be negative, 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 negative. That's why we will minus them all the time here. That's another interpretation also aside from using English language in the term. This is the way how we understand and memorize. Okay, so minus, okay, the change in the freezing point. Ano ra siya? Change in freezing point. Change in boiling point. The important keyword here is the change. Delta. If there's no delta in the problem solving, it will really mention change. Okay? Or using another terminology, a deviation from 20 degrees Celsius to 60 degrees. Deviation means also changes from the original to the final, from the former to the later. You get the point? So we need to say, there's a lot of how to phrase all the time. That's why in the problem solving, you are really advantaged if you can interpret well the phrasing of English language. Everything, the conjunction, the words, you know, so that you can understand really how to interpret, and then if you have a really smooth analysis of that particular problem. So especially for us that we are not really fast learners, average only, a little above average, okay, because as I told you a billion of times, math is not my superior favorite subject. Okay, things like that. I just love it because my course is chemical engineering. I don't have choice. And then I start to love it until first year college to fifth year college until I became a registered chemical engineer. Okay, things like that. Okay, now, delta here is change, right? It's very obvious. Here change, here final. The same story with the boiling point. We say, the new freezing point. Okay, freezing point elevation. Okay, and then the final temperature of the solution after freezing. The final temperature of the solution after freezing. Or sometimes only shortcut. What is the final temperature of the solution? No need to say after freezing because the process is freezing. You get the point? So there's a lot of how to phrase it. Me, really, I'm confused when I was in first year college for this topic. because these topics, colligative properties, are not clearly explained in high school. Okay, though it was explained, but not really that in a manner of what do you call this one? Not tremendous, enormous discussion. Enormous meaning lengthy, wide, like that. You get the point? You get the point? Long discussion. That's enormous. Okay, things like that. It's just very quick. Okay, ganon. So if we say, what is the total freezing point of the solution? What is the final temperature of the solution after freezing? What is the new freezing point? What is the freezing point elevation? Ang ipangitaan na ang final. Okay, ang solution. Now if asked, what is the change in freezing point? You don't have to deal with the solution. Just follow this formula for delta change chuva. Okay, this one, delta change TB, delta change TF. You don't have to go to the solution. Because if you use this final chuba, solution, you need to account the water. Okay, for boiling point elevation, boiling point of water at 100 degrees Celsius, add it. Okay, for the freezing point, depression, freezing point of water at 0 degrees Celsius. Okay, the negative chuba, that's why minus. Alangan man, kung dako siya di, makuha na noon siya. Okay, get the point? Anak siya, no? Okay. Now, you will put only negative here, ha? You'll put negative here if you plus here. You say, freezing point of water plus TF. This is what we call absolute chuva. Within the absolute, we need to follow the standard and we carry the sign. Because if you put the negative values here, negative, okay, the answer also will become negative. So 0 minus negative, minus this one. Okay, we don't carry the negative, so it will negative answer. If you put the plus and negative answer already here, it will become also negative. So 0 plus minus negative. So just like saying 0 minus. Me, in my part, I don't carry the negative because it looks confusing somewhere in the here. But if you are convenient for that also, you need to use the TF, freezing point of water, okay, plus the change in freezing point. Because the answer of your change in freezing point here is always negative because you carry the negative KF, which is 1.86 degrees Celsius over L. But if you don't want to carry the negative, don't put that in your formula, then you need to subtract the freezing point, okay, of water to the changes in freezing point. I love this analysis because of the term depression. It's easy for me to remember, depression, okay, subtraction. So that's why I need not to be bothered with this plus, with the science chuba incorporation. I don't like really, okay, get the point? Especially if it deals with science, I go to the English language terminology, okay, not on the how it is being solved by the teachers, like that, whatever. Okay? Okay, naka-standard ba sila sa the way how it is being taught from the old people also to them, and then teach again how it is being taught by the teachers before. Me, I don't like that, okay? Meaning, if I will be a teacher, I need to establish my own originality, my own creativity, that it would be different, but in the same manner, they can still get also the correct answer. Very precise, just like a spoon feeding, like a baby. Okay, you get the point. Though it's very tiring and exhausted, you get the point, but it's really rewarding. You get the point, things like that. And you will be fulfilled to that. Okay, things like that. Okay, now number 3, vapor pressure lowering. Remember, vapor pressure lowering. So, English terminology, the vapor pressure will lower. Right? English. And then Baden formula. Number 3, vapor pressure lowering. So, meaning to say lowered, ha? It's not increasing. Then the moment you have a very high vapor pressure of the solution, wrong. Okay, because your analysis is you are not following the captioning or the heading of that particular equation. If you will say elevation, it will elevate it really. It goes high. The moment it will goes down, then it's wrong. Even though how perfect you make the solution, chuba, chocho, like that, but it's going down, it's not following. Okay, maybe you are wrong in the writing, too much messy, and then you forget because your eyes are getting tired, or clerical error, whatever, things like that, okay? So vapor pressure lowering, so partial, nakakaloka, partial pressure of the solution. I will teach you also why, okay? Partial pressure of solution is equal to the mole fraction of solvent or liquid. Because this area is the most confusing part, because when we say of solvent, any liquid, okay? But if we say H2O, it can only be an H2O. But some teachers will always put the mole fraction H2O even though it's not already H2O. You got the point? So things like that, it should be solvent mole fraction of solvent, mole fraction of liquid, because that is not H2O already in your solution. Maybe they will sometimes also, what we call this one, forgot only. Okay, get the point. So mole fraction of liquid, okay, and then times, okay, times, asa mo hindi mo siya i-times. Okay, solution lang siya, the pure vapor pressure of your solvent, with liquid also. Okay, now, liquid is the same as solvent. Now, solvent is not really the professional term in chemistry, in calculation. It should be liquid all the time. Okay, in calculation, ha? I'm only saying calculation, but you can speak that in your public speaking or your reporting as solvent. No problem, but in calculation, always liquid, solid, liquid, solid, liquid, solid, liquid, solid. Okay, like that, okay? Get the point, ganon. Now, take note, guys. Here is pure. Here is pure. Meaning, the mole fraction of your pure liquid. Okay, things like that. And then, the vapor pressure of your pure liquid. So, the word pure is very important to determine your concentration. Okay? And then, the word pure is very helpful also because most of the pure substances have standards at standard ambient temperature and pressure at 25 degrees Celsius. That's why most of the books don't put the 25 degrees Celsius because it means pure already in the equation. Don't wait to put 25 degrees Celsius, where in fact, in the discussion of the book, it says the mole fraction of the pure liquid times the vapor pressure of the pure liquid, and it was mentioned already there H2O, because pure means in science obeying ambient temperature and pressure. Okay, this is the technique also. The point, because others also wait for the temperature to be mentioned, and if there's no temperature to be mentioned in that particular problem, they will never use that anymore equation. They will look for another that involves temperature. Wala, nanganga. You get the point, things like that. Okay. So, ganon siya, no? So, the word pure is important. But, of course, I will not normally say also every time pure. During only my introduction of discussion. You get the point? But my point here, the instructor and professor will always really see pure in his first introductory discussion in this topic, because that is the very important part, the introduction. Okay? In every performance, like a singer, dancer, in a competition, introduction is very important impact. The moment you will mistake there, you will never win. Same also with problem solving and discussion. The moment you discuss not very clear to the students, they will just solve it just like the way how they understand. Okay? But we are not sure that the way how they understand is always correct. Okay? Unless they are guided accordingly by the professor and the teacher for the very first time in touching the particular topic. Okay? Ganon. Okay, ganon siya ang vapor pressure, no? Vapor pressure lowering is equals to the, okay, look at this. This is very confusing also. Some books say partial pressure of solution. That's why, guys, when I study in college, I will never be satisfied with one book. I will go 3 books, Sorry, I did not told my classmates about this because if I will tell them maybe I cannot be understood, right? So that's why I kept on myself on my college days, home study, library, home study. So I will never go to watch cinema and in the city, in the Colon, I will never do anything like that. Just study always, okay? So mo to na akong mata murag nakuan gid siya, guys. Okay, things like that. Tanawa akong mata. Okay, things like that because grabe jud ko makadag kuan ba, di ba? Ganon. Okay, so I found out, guys, that a lot of authors discuss in different ways. Now, if you only refer to one book, you rely on that, you will be dependent on that particular book. Then, in examination, it's the pattern in that particular author of that book. So they will revise it, modify. The more book referred, the more it is good for confirmatory and for better understanding. Oh, here, sometimes you will say, the partial pressure of the solution, I'm talking with the vapor pressure lowering. Partial pressure of solution. Some books. Okay? English language tayo dito muna ha, before tayo mo partial pressure of the solution. Some also books will say, partial vapor pressure of the solution. Another. Okay. Other books also say, vapor pressure of the solution. Okay? Ang saan mo kitinood ani? Vapor pressure of solution. Nakakaloka. Okay? Others also say, partial pressure of the liquid above solution. Some also say, vapor pressure of the liquid above solution. Okay. Things like that. Now, in saying vapor pressure of the liquid above solution is very confusing because you are only referring to liquid, not for the entire solution. But take note, vapor pressure above the solution, meaning to say it's not dealing with solution because it's only above. Again, in English, preposition. You get the point? Detailing the location, things like that. But other students will solve the vapor pressure of liquid because the word liquid is stated already in the words. Okay? Especially if they will fast in solving, you will interpret vapor pressure of liquid. But it's totally different, the vapor pressure of the liquid and the solution. That's why also I think some books eliminated the liquid. When they say, they will only say vapor pressure of solution. That's why they adopt the standard vapor pressure of the solution lowering. Okay, when you say vapor pressure lowering, it talks about the solution, or it talks about the pressure of the liquid in the vapor phase in that particular solution, or the vapor pressure of the liquid above the solution. Because, why it makes sense? Because your formula are always talking with the liquid. Take a look. Pure vapor pressure of the liquid, pure mole fraction of the liquid. Then you think that the solution is not in terms of liquid? It's also in terms in liquid, but in the entire solution. It makes sense, right? In English language. Get the point. Ano to siya pagsabot? Ha? Okay. Things like that. But if you want really direct chuwa-chucho, let's say, vapor pressure lowering. Ganon. Hindi mo rin i-understand na solution niya per me. Okay. So, kung gusto nyo kang ana yung pagkasabot, no problem. Because it depends on the students, fast, and quick, what they call this one, IQ. Okay, get the things like that. But here, guys, is vapor pressure of the liquid, okay, at pure. Pure meaning at 25 degrees Celsius. Now, since most of the times water. In my case in college, I memorized that exactly. Okay? I don't refer to the chemical engineer's handbook. I just put that in my brain always. That is 23.8 torr. Okay? 23.8 torr is the standard pressure of pure water at 25 degrees Celsius. I noticed that because most of the times, it is the sample problems in the books. Water. Then why should I don't memorize it? In your part, am I correct or not? Okay? Then if you try to scan the chemical engineer's handbook at very simple value, then it will consume your time, things like that, blah blah blah, so and so. So you are already dependent by just a simple 3 digits to 38 point something. So, i-memorize na lang niya siya. Just like the specific heat capacity, like that, heat capacity of water, because water, ice, steam, CO2, CO, air, ammonia, magbalik-balik na siya sa problem solving. You get the point? Things like that. Keep on repeating, keep on repeating. So, if the problem solving involves in CO2, kalas. Okay? Tuloy-tuloy ang ligaya. Ganon! Okay, things like that. Monaco style when I was in college. Okay, so again, the vapor pressure of pure liquid at 25 degrees Celsius is 23.8 torr. Now, what is the value in atmosphere? As I told you a billion of times, we need to maximize all the units of pressure so that when we solve problems in the future, we will not be confused always, and we are always looking for the given and the data, paklik sa handbook, whatever, like that, but there's no open books, right? So how can we do that? Memorize and understand. Okay, so there are 7 units of pressure. mmHg, pound per square inch, bar, torr, atmosphere, Pascal, kilopascal, and Newton per square meter. How much? 1, 2, 3, 4, 5, 6, 7, 8. Now, memorize them all so that no escape during problem solving, because most of the times deals with pressure and temperature. You get the point? And temperature is very easy. There are only 4 formulas: the Rankine, the Fahrenheit, the Celsius, and you memorize also the formulas of this temperature changes. No problem. Very easy also. I think I could say very easy because I love it too much. Others also don't love it kasi kaya nga siguro they don't memorize also. They are just memorizing it for the purpose of having a grade. Just to pass. But me, I really need to memorize in order for me to learn, and I can use that in daily life, in normal situation. If somebody will ask me, "Oh, so tino compute that," and I can give them the answer, things like that. What is the volume of this? So I'm ready to answer them if they will ask me. Of course, it will be reserved in my brain cells unless somebody will ask me. Because they will interpret me as a fool or crazy if I will say something and it's not related to the present situation. I'm just only answering them if they will ask me. If they will not ask me also, then it will be kept and reserved in my part. Okay, things like that. But it doesn't mean I'm not willing to share. I'm willing to share. It's just happened. Nobody asked me. Okay, since I have the opportunity to be a vlogger and a content creator, then I have to share that in my virtual platform or online platform of discussion to share academic information. Okay, now mmHg. Okay, this is the unit of pressure in blood pressure measurement. I'll say 190/80. Meaning to say 190 millimeters mercury over 95 millimeters mercury. Why? Because pressure is not unitless. All pressure have units. Okay, so if the doctor will say 90/80, it doesn't mean that there's no unit. How come the pressure become a pressure without a unit? So we are practicing the wrong thing, precisely and accurately. To be professional and technical, precise and particular, we need to mention really mmHg. But since we are loving of shortcut way, like this, it takes time to ask mmHg, millimeters mercury. That's why we don't say it anymore. For understood already. What about the children? They cannot understand easily. So we need to educate our children. Then we need to express that fully. Millimeters mercury, millimeters mercury. It's very easy, right? So in a world of social media, a lot of cutting words, a lot of abbreviation. That's why in terms of, I could say, what do you call this one? English language total comprehension, our young generations are not very good. I think so. They're only good in the innovations of the computer, the way how they manipulate creativity, the animation, content wise, video effects, special effects, but let them speak in English fluently. I think they cannot. Some can, but I think most can. Because we know our generation of today did not discuss the proper way. Okay, we just leave it too much abbreviation, too much abbreviation, too much abbreviation like that. BTW, by the way, LDR, long distance relationship. What's this? Our children will understand this. By the moment they will go out, grow old, that's the time they will understand. But at an early stage, they will never understand. So how can they become clever? Things like at an early age. You get the point? Ganon. As parents, it's our responsibility to teach them, not shortcut all the time. You get the point? Ganon. Because family is the basic unit of the society, which the education starts first, not in the school. Okay. So mmHg. So 760 mmHg is equals to 1 atmosphere. Ganon. Okay. 14.7 psi, meaning pound per square inch, okay, is equals to 1 atmosphere. Okay. Bar. 1.013 bar is equals to 1 atmosphere. Literally the same. But if the examinations have very sensitive, numbers, especially multiple choice, you need to take extra careful with the point something because it matters a lot, especially if the choices are very near. Okay. But most of the teachers rounded off as equal. 1 bar is equals to 1 atmosphere. But in my part, I don't treat them equal because sometimes it's very strict in problem solving. That's why 1.013 bar is equals to 1 atmosphere. Okay. Now, torr. 760 torr is equals to 1 atmosphere. Okay. Like that. Pascal. Okay. 1 Pascal is equals to Newton per square meter. Newton per square meter is a unit of pressure also. Because of the formula in physics, okay, pressure is equal to the applied force applied perpendicular to the surface area. Basic concept again. Okay, so pressure is equals to force over area. Okay, the unit of force is Newton and the unit of area is square meter. Therefore, Newton per square meter is a unit of pressure also. Okay, but in a quantifiable manner. Okay, then we have Pascal. Okay, 101,325 Pascal is equals to 1 atmosphere. Again, 101,325 Pascal is equals to 1 atmosphere. Okay, now kilopascals, very easy. Divide by 1,000, right? It's gonna be 1.01, okay, kilo man siya, right? So 1.013, okay, kilopascal is equals to 1 atmosphere. Okay, and that's perfect, class. Okay, now, there's a lot of pressure. Atmospheric pressure, vapor pressure, partial pressure, absolute pressure, okay, things like that. Pneumatic pressure, hydraulic pressure, things like there's gauge pressure, normal pressure, standard pressure. You need to understand each definition, what's the distinction between them, so that during problem solving, it's easy for you to adopt what kind of pressure is that compatible to that particular problem. Okay? Ganon. We have also absolute pressure, vacuum pressure. You need to understand also everything about pressures, the variety of pressures. Because we mean pressure only one. No, it's not. There's 9 types of pressures. Okay. Okay, that is vapor pressure lowering is equal to the vapor pressure of the liquid above the solution is equal to the mole fraction of the pure liquid times the vapor pressure of the pure liquid. Okay, number 4. in colligative properties, the last in our theory explanation. And after this, we need to go to the proportionality explanation. What do you mean by proportionality? Meaning, analysis, what will happen if this will rise, if this go up, because it will help a lot in our answers. Okay? That is proportionality relationship. Okay, things like, then, okay, from our equations, we can understand that. Okay? Last will be the osmotic pressure. Okay. Osmotic pressure under the topic of osmosis. So, very strange. Our formula for the pressure is pi. But we understand this in math as 3.1416. For example, what is the circumference of a circle? 2 pi r. 2 times 3.1416 times the radius. That's the circumference of a circle. What is the area of a circle? Pi r squared. What is the area of a sphere? 4 pi r squared. And a lot more. Okay. So, pi here is not the 3.1416, but instead the pressure. Okay. Is equal to the capital M. Capital M here is not the molar mass, it's not the molecular mass, it's not the molecular weight, but it is the molarity. The molarity. Okay, the unit is M, capital M also, or molar. Meaning, molar, moles of solute over liters of solution. Okay. Meaning, that is quantifiable by volumetric analysis. You get the point? Things like that. Volumetric analysis. Okay? Para klaro. Okay. So, we have here, multiplied by our universal gas constant. Charot. Ganun ba yun? Constant. Ganun talaga. Constant. Now, guys, memorize also the universal gas constant, at least 3 or 2, and the rest you manipulate that to the STP, standard temperature and pressure, okay, in dealing with the 1 mole of an ideal gas by the general gas equation and also the ideal gas equation established by Clausius-Clapeyron, the man behind ideal gas law. Okay, things like that. So we have R times capital T. Okay, now, our R here is the universal gas constant. Some also will say gas constant only. Some will say universal gas constant. Some will say also as osmotic pressure gas constant. But just to remember that it's only a gas constant, no problem. Okay? I'm just trying to be precise. You get the point, things like that. Okay, so capital T, it depends on the unit of your universal gas constant. Okay, it's very clear. Okay, now, if you use 8.314 joules mole Kelvin, okay, you will use T capital T, which is Kelvin, discovered by Lord Kelvin. Okay, things like that. So 8.314 joules per mole Kelvin. Okay, now if it involves liters and atmosphere, okay, then you use 0.08206 liter atmosphere mole Kelvin. Did you nyo makalimtan, guys? If you pasok this in your hippocampus part of your brain cells always. The 2. Okay? Ganon. Balag duwara. Okay, okay na. You get the point? The rest will follow. You get the point? Ganon. Okay, diba? Okay. So, ano na siya? Charis. Nakakuha mo, guys. Muna na siya itong osmosis or osmotic pressure. Charus. Okay. Now, guys, char. Okay. Muna na siya, no? Okay. I will say also that in every 1 liter atmosphere is equals to 101, okay, 103.1 joules. Then, liter atmosphere is a unit of energy. Because of the first law of thermodynamics that states that work is equals to the negative P times the change in volume. Okay, so work, the unit is energy. So therefore, later atmospheric pressure and volume, meaning this is energy. Sometimes this will be a trap, and a trick also. Because sometimes, what's unit is that all about? Things, I mean, it's not always expressed, right? You got the point, things like that. Okay, especially this one. This conversion is a little bit strange. Okay, so 1 liter atmosphere is equal to 103.1 joules. Okay, you get the point? Ganon. Okay, so how many joules in 1 calorie? So 1 calorie is equals to 4.184 joules. Okay, then 1 big C calorie is equals to 1,000 calorie. Ganon. You got the point? So 1 kilocalorie is equals to 1,000 calorie also. Meaning 1 big C, small letter A, small letter L calorie is equals to 1 kilocalorie. But the small C, A, L calorie is not the same in value. So the moment you make it capital, the value will change. So be careful in this 2 calorie. Okay, again. 1 calorie, which is small letters all, C, A, L, the value is 4.184. Now, if we say 1 calorie and it starts with a capital letter, C, A, the same letters, but the only letter is capital. The value will 1,000 calorie. There's a great difference for that. That's why you need to understand during your memorization. Somewhere here. Okay? You get the point? Ganon. Okay. And we can say also that, okay, 1 horsepower is equals to 746 watts. Okay. 1 watt is equals to 1 joules per second. Things like that, okay? Now, 1 ampere is equals to, okay, coulomb per second. Coulomb per second. Therefore, 1 coulomb or electric charge is equivalent to 1 ampere second. By manipulating the algebra. Okay? You get the point? Oh. 1 coulomb is equals to 1 ampere second. Then 1 ampere is equals to coulomb per second. Okay, these are all conversions in engineering. And there's a lot pa, no? Okay, so I cannot accommodate all here in the whiteboard. Very small. Okay, our constant, Avogadro 6.023 times 10 to the 23 per mole. Okay, our value of our coulombs constant, 1 electric charge is equals to 1.67 times 10 to the negative 19 coulomb. You get the point? Our Boltzmann constant discovered by Ludwig Boltzmann in 1872 is, okay, that is 1.3872 is, okay, that is 1.38 times 10 to the negative 23 joules per Kelvin, the unit of, what's this? The unit of the randomness and disorderness of the system, entropy, delta S is equals to Q over T. Ganon. Okay, and there's a lot of constants you are trying to remember. It depends on the situation, what kind of problems you are trying to solve. Okay, things like that. Ganon. So, natapos na taning colligative. Now, let's go to the summary. Okay, summary chuvas. Now, colligative properties limitations, okay, it will not go to not dilute solution. Okay, not diluted solution. Okay, and then it will not apply if there's gas in it. Gas. Usually solid and liquid. And sometimes also liquid, but in vapor pressure lowering only. In our Reel's law, another version. Because we have 2 versions of Reel's law. And I may explain, I don't know this in college, but when I researched too much, I found out, there's 2 ways of Reel's law explanation. Things like that, okay? Reynolds law explanation. You get the point? Kinadugay nila akong discover. Okay, things like that. Things like two versions, the liquid and the solid liquid. Okay? Things like that. Okay. Ang kani siyang liquid dito na siya metabo sa extraction topic sa physical chemistry. That's still Reynolds law. Okay, things like that. Muna na siya no, not diluted, and then the pressures are always very not very low pressures. That's why vapor pressure lowering. Okay, it makes sense, right? So applicable for low pressures. Okay, things like that. And diluted solutions, meaning ideal solutions, right? Meaning to say, you will not consider the, what do you call this one, adiabatic process. Okay, like that. Okay, because the heat flow is zero. Okay, there's no delta H, there's no change of enthalpy, there's no enthalpy of mixing, things like that. There's no change in volume. Okay, as you can always discuss in this particular topic, you will never touch this, giving too much like this, right? Because that's the conditions of our colligative properties. Ganon. Okay, things like that. Diba? Okay. But again, the concentration is very important. Because it depends on the solute concentration in the definition itself, colligative properties. Okay, but not on the chemical identity and the nature of solute and solvent. Now, we go to the connection for this. What are the factors affecting solubility and concentration? Again, enumeration. 4 examples. Okay, temperature, pressure, nature of solute, nature of solvent. 4. Okay, diba? What will happen if you increase the temperature of a solution? Ganon, diba? Then you need to be precise. Sir, what kind of solution? Liquid, liquid, solid, liquid, gas, gas, because these phases have different molecules. We cannot say in general. For example, if I have solid and liquid in my beaker, okay, solid and liquid in my beaker. If I will heat this and increase the temperature, normally the concentration and solubility of solid and liquid will increase because there's a very strong kinetic energy, okay, and strong molecular forces, and then it will escape to the atmosphere and the volume will become less. The moment the volume will become less, the solubility increases. Okay? You get the point? Things like that. Now, in a liquid gas solution, this is gas here, this is liquid here. The moment you will increase the temperature, okay, it will not increase, okay, the concentration of a gas. Okay, it will decrease because, you know, here in the gas phase, the molecules are very farther apart together. Okay, then you heat pa. Then the more it will decrease. You get the point, things like that. So, it will not matter here. So, you mean to say, if you increase the temperature, then the solubility here will decrease in case of gas and liquid mixture or so. But in solid and liquid, if you increase the temperature, both the solution, solid, liquid concentrations will increase. But here, it's not. Okay? You get the point. So, the concentration of gas will decrease. Okay? You get the point. So, what will happen to the concentration of liquid? It will increase. Okay? And in the solution, overall, how can you say in a solution? It will decrease. Okay? Things like that. Because liquid are staying for a while. You get the point? You get the point? Things like that. And then, you know, here, there's a greater rate of, what do you call this one, guys? Graham's law of diffusion. If you can still remember the theory. Graham's law of diffusion. Right? Or the rate of effusion. What's the difference between effusion and diffusion in our unit operation? I think it's gonna be heat transfer. Wait, no, in the humidification topic, I cannot remember. But there's a difference between effusion and diffusion. Okay, now I will tell you honestly. Charot! Okay, now, in your effusion, okay, meaning to say that is a process in which the gas particles travels, note the action verb, travels, moves, passes, escapes. I use four action verbs that means the same thing. You get the point in my definition. Again, effusion, the process by which gas particles travels, moves, passes, escapes into a tiny hole, okay, of a material. Material here is very general. It could be a vessel, tank, confined space, pipe to tube, venturimeter, like that, an elbow, 90 degrees pipe, things like that, the pipeline network, or let us say heat exchanger, things, whatever, as long as there are holes that these gases can go inside and penetrate. You get the point, things like that. That is effusion. Now, what is diffusion? Actually, they're all the same, but there's a specific, certain understanding that makes them different in a little way. Okay, things like, so diffusion, meaning a process, same the same, gas particles, okay, in which, okay, the gas travels, okay, moves like this, but not passes and escape. Okay, only travels and moves, okay, but spreading out. Spreading out, not necessarily mean it will go into the holes. It could be they will go in the holes, it will escape, it will go back, it will go up, it will go down. That's the term spreading, meaning turbulency of your molecules. There's no exact momentum with corresponding positioning and velocity at that particular moment. So there's a lot of magnitude and vector of your particular movement of your molecules accelerated in a material with a corresponding velocity, pressure, things like velocity, pressure, acceleration, mapuyog sila perly once the particles and molecules move. Velocity, acceleration, force, momentum, things like that, impulse, viscosity, you get the point, pressure, surface area. These are the quantities that always kept repeating in your equations. As you can notice this, some of it will drop out, some of them will remain. Okay, now, if there's losses, you need to account the fraction and viscosity. What's the difference between fraction and viscosity? They have the same connotation and idea, but the phases and the materials of contact are the same. Different. When you mean of friction, that is the resistance to flow in a solid materials. Remember, solid. Just like running, driving a car, pushing the cart, there's a friction in the solid. But this friction you cannot apply in the gas term or in the fluid. The right term there is viscosity. Viscosity is the resistance to flow of different fluids and gases in different particular medium. Now, remember the keywords so that you can modify, rephrase your own definition. You get the point? Meaning resistance to flow. Then, okay, resistance to flow, or meaning to say restricting to flow or opposing to flow, things like that. Then make your own sentence out of that. It will connect verbs, adjectives, like that. Then you can have your own definition. You get the point? Remember the phases also, where this friction and viscosity will be contacted or will contact or will travels, things like that, so that you can define friction in a very quick manner. I would say, Junjun, what is friction? Oh, you can see immediately, without question, what is viscosity? Di kayo mapakli-pakli sa libro. And then, Google search in mobile data. Then you don't know what is the simple definition of friction. You don't know also the simple definition of viscosity. Pwede na kami friction, the opposition to flow. Ganon. Litsura. Okay, but if it's an examination, you need to have a compound sentence, complex sentence, so that it will add clarity of your point. Then, is a exam, then you have 10 points, 20 points, 30 points, rather than saying opposition to flow. What? But you are only asking for the straightforward meaning. That's why you need to answer it in direct manner. Okay? Questioning in a very casual way. Just like a colleague or somebody else will ask you. You don't need to be precise all the time with the definition. You get the point, things like, but the way how you write, in essay, feasibility study, examination, written examination, or whatever, then you have to be precise. You get the point, things like that. Okay, so magkuyog din siya ganang English language, no? Okay, things like that. You get the point. So, mauna siya. Okay. Any questions so far with our colligative properties? Now, summary. Uy, mag-summary na ta, uy. Guys, mag-summary na ta guys, uy. So thank you so much for watching this video. I hope you like it and see you later on another topic of this vlogs. Bye-bye. God bless everybody. Remember that Jesus loves us. Bye-bye for the science world of your YouTube content creator, Junjun Inglesero. Bye-bye.